Okay, this is going to be your first lab. In this lab, we are going to be interpreting a seismic data. The Now I've given you a seismic map. Here you have three horizons, A, B, C, and they have been colored for you. This is the first one, A, the second one in green, and the third one, C, in purple. Now what you're going to be doing is, you see, you have all those faults, 10 faults, 1, 2, 3, 4, and they be numbered for you, 1, 2, 3, up to 10 faults. So you're going to be looking at where the horizon crosses each fault. There must be a jump. Okay, sometimes the jump is not really visible, but you have to, I just gave you instruction to assume it's 1 millimeter if you can't measure it. Now, the first thing, before you even measure that, the first thing you have to measure, you need, for this class, for this lab, you need a ruler and colored, you need a ruler, okay? Then, and colored pen. Now, the purpose of the colored pen is, once you print out this paper, since it's going to show in, unless you can print it in color, but if you print it in black and white, you need the color to retrace the horizon so that it's going to be easy for you to work with. Now, the first thing you do actually is to measure, see, to create your scale. So you have to measure, this is the two-way time. So you have to measure from 100 to 1100. That is going to be 1000 milliseconds, which is 1 second. So you got to measure what is the length. You use your ruler. See, you use your ruler. In this case, I'm going to measure from 110 to 100. You have to use the millimeter. You see, the millimeter is there. Millimeter is the small graduation. Okay. So those numbers here, they are centimeters. Okay. Now, let me see what this one is going to give me. I'll tell you now. This one is 130. Okay, no, it's 130. It's 130. It's 13 centimeters. Actually, 12.9. That's 129. Let me measure again. No, it's exactly 13. So it's 13 millimeters, 13 centimeters. So I'm going to open my Excel. 13 centimeters is 130. So instead of 80 here, I'm going to put 130. That's 13 centimeters. So my scale now will be calculated, which is, I've already put the formula there, so it's going to calculate your scale. So whatever measurement you measure, the scale here is going to convert it to seconds. Because this is for 1 millimeter, this is how many seconds. So if I measure 1 millimeters, so it's going to, so if I, for example, if I measure 10, no, let me go measure another one so that you, now your own scale will be different, okay? So don't use my scale. Because I got 130, doesn't mean you get 130. My own scale is going to be different. So what you are going to be measuring actually, after you establish the scale, the jumps. Let's look at this. I'm going to look at the first horizon, which is sandstone, and the fourth, number 3. See, got the jump. It jumped from here to here, but you have to measure vertical. Okay. So I'm going to be measuring from here to here. Measure vertical. Let me do the measurement. I'm measuring 7 millimeters. Oh, I'm measuring 6, sorry. So I measure 6 millimeters. So I'm going to put for, that's, okay, see, for number 2, for horizon A, for number 2 is you cannot measure it. So I'm just going to put 1 millimeters there. So I go back to so for sandstone, foot number 1, foot number 2, I put 1 millimeter too. Foot number 3, I measure 6. So I put 6 there. So these are all still sandstone. You grab that and you copy it. You grab that corner and you copy it. You drag it. So that will copy to all of them. So I have to do the same thing here. My mouse is misbehaving, that's why. Okay, so the same thing. Actually, if you double click like that, it will copy to all of them. Okay. So it's going to be doing all the calculation. As you measure, you put your measurement, it's going to calculate the number of seconds. Then from the velocity here, it's going to calculate the actual throw in meters. So that's what we want to get. We want to get the throw in meters. So first of all, you measure the millimeters. On your scale will convert it to seconds. And then if you multiply that by the velocity divided by 2, because this is a two-way time, that will convert it to the actual throw in meters. So that's what you're going to be doing. So you do for sandstone, then you pick up the next one, which is shale. You write shale there. Then you write I think the velocity for shale is 2100. You write the velocity there. Now, what you're going to notice is that the shale is not going to pass through the same fault. All this one. Sandstone passes through all these faults, 1 to 7. But let's look at the shale. The shale will cross. See, the shale cross the first one. It crosses fault number 1. Actually, all of them crosses number 1. So all of them cross number 1. Number 1. Then it skips 1, 2, and 3. So it goes, okay, it doesn't skip 3. So from 1, then the next one is number 8, then number 3, number 9, number 10, number 6, and 7. What you notice is all of them, all the 3 horizons, they pass through 1, 6, and 7. That's the only common fault. Otherwise, they don't pass through all of them. So that's what you're going to be doing. You just, once you are done with your table, all your measurement, you save it and you upload it. That's it.